Okay.
We are going ahead with a greedy approach, and we consider the nodes with homogeneous class distribution are preferred, that is our idea, and we need to measure the node impurity. Okay. I just need your response. Hello, my dear students. Hello.
Hello. Any voice? Okay. Students, you please respond to me on chat. If you have any problem in understanding, respond to me in chat.
So you
have nodes with homogeneous class distribution are preferred, that's what I say. And we need a measure of node impurity. Okay.
See here, when we are considering the node with impurity, yesterday we had a discussion just to have a quick review of what we said yesterday. We discussed about a kind of split. We thought that we will be focusing on three major issues. That is like how do you discretize the variables, and how do you choose the best split. So these are the important issues we have. So determine how to split the record space. We discussed that you can have a binary split of nominal attributes and ordinal attributes we discussed, and how the numerical attributes also can be distributed, we discussed. Right? And yesterday I have given you an example. This is the example. If you look at, we discussed that there is a college where the students will be coming by their own car. Some of them do not have own car. And another field is car type, another student type. And we found that car type distribution is giving a better split. Okay. To see that is fine. That is fine. But how to quantify that? That is an issue. So here, for that we are using the measure Gini index or the entropy. So you look at one thing with C05 and C15. That is you have equal number of different category of records in the same course. Second is homogeneous. In this you have 9 of 0 time and 1 of 1 time. This is with a low degree of impurity. If it is a perfect class, all elements should belong to the same class, but it is practically not viable. You have some degree of impurity shown there. So now, how do you measure this kind of impurity? The measures are Gini index, entropy, and misclassification. In this we consider Gini index and entropy to be better things. Now we just consider one example. This also we discussed last time. You will have the numbers before split. You will find out the gain. And we consider that two splits as two nodes, and you have the nodes M1 and M2, and you find out the individual gains as M1 and M2, and the difference of M0 and the M1 plus M2 you find out, that is the gain. And in the second case also you work out similarly, and whichever is higher, we consider that is the thing with best gain. Now, how do you define the Gini index? Gini index of a node T is 1 minus sigma of P
j by t whole square. What is this pj by t?
This is
the relative frequency of class J at the node P.
That
That means
the elements
belonging to class J
over the
total number of elements will give you
your
your
pj
pj by t.
So
1 minus sigma of
pj
pj by t whole square.
That means if you
That
have
means if
two
you have two
classes,
classes C0 and C1,
then you will have
two
two
things.
That is
probability of class 1 elements, probability of class 2 elements. So P1 by 2 and P2 by 2. I mean to C1 by 2 and probability of C2 by 2. Now for this,
if you
maximize 1 minus 1 by NC, when records are equally distributed among classes, implying least interesting information, that means you have more disorder. Minimum 0.0 when all records belong to one class, implying most interesting information.
See here, we will see the different values for C1 and C2 and how Gini index varies. If you look at C1 class has 0 and C2 class has got 6. Okay. Now if you consider your Gini index, that is 0. Why it is 0? Can you please tell me, my students, why it is 0? It is defined as what is the probability of it? First when it is C1, it is 0 except the number of elements. Right? So that is 0 square. Plus second one is 6 by 6 is 1. 1 square. 1 minus 1 square is 0. Are you convinced with this? JNTUK Kakinada. Hello. JNTUK Kakinada or Vijayanagram, please respond. Is it clear to you? Work chart. If you have any queries, ask me. Okay. Now. Pragati complains that there is no voice. But here on the systems and from Vijayanagram also, voice is clear. Pragati, you please check your audio system. It is problem with your audio system. Okay. Now, observe the second one. You have one element of C1 class and 5 elements of C2 class. Now see the Gini index. For C1 the probability will be 1 by 6, right? And for C2, regarding this, I will tell you later. Normally, we refer to this as Gini index, but I have no clue about why the name is given. But I will probably refer and tell you. It's a good question. Generally, I never thought of it. It's good that you raised. I'll tell you what does it stand for. Okay? Now, if you look at the second
second set, you have one impurity there. So C1 has got one element and C2 there are 5 elements. Now if you look at the Gini index, the probability of C1 is 1 by 6. Probability of C2 is 5 by 6. Now the Gini index will be 1 minus of, within brackets, 1 by 6 square plus 1 6 by 5 whole square. So that amounts to 0.27. So that amounts to 0.278. Now see, when there is no perfect impurity, Gini is 0. And when there is impurity of 1, it is 0.278. Now observe here, C1 is 2 and C2 is 4. So the impurity has increased, right? When this impurity has increased, the probabilities are 2 by 6, that is 1 by 3, and 4 by 6, that is 2 by 3. So it will be 1 minus of, within brackets, 1 by 3 whole square plus 2 by 3 whole square. That amounts to 0.444. Are you getting the point? Now C1 and C2 both are 3 each. In this case, the probability is 1 by 2, 1 by 2. So it is 1 minus of 1 by 2 square plus 1 by 2 whole square. That is 1 by 4 plus 1 by 4. That is 1 minus half. That becomes 0.5. So now if you look at the Gini index, when there is an equal distribution of all category of items, that means the entropy is, the uncertainty is more. It is not a classified one. The distribution has got equally all kind of items. So the maximum disorder is there. When the maximum disorder is there, the Gini index amounted to 0.5. Similarly, you have entropy also. Entropy will be 1 when it is maximum. It is sigma of minus P log P. Okay, that also I will define later. But both are of same structure. Basically, if you look at the graph of Gini index as well as entropy, the graph will be a half sinusoidal wave only. At 0, Gini will be 0. And at the maximum thing it is 0.5. Again, if the impurity becomes less, like 3, later if you say 4, then 5, 1, then 6, 0. In that case also, on the other side you will have on the quarter. You can see the diagram in subsequent pictures. So the Gini index is increasing means that implies you have more uneven distribution. That is the meaning. See the calculations are shown here. 1 by 6, 5 by 6, 1 minus 1 by 6 square, 5 by 6 square, 0.278. When it is 2 and 4, this is like this. Okay. Now if you look at when a node is split into k partitions, how the quality of split is computed. For two things I have shown. Because Cart and SLI given string algorithms they use. These are different algorithms that are based on decision tree aspects only. There will be minor variations in implementation. That's why you have got different algorithms. Okay. When a node is split into k partitions, let us say, how the quality of split is computed. So the Gini of split will be, suppose there are k partitions, so I is equal to 1 to k.
of Ni by N into Gini of I, where Ni is the number of records at child I and N is number of records at node P. So that means N is the number of records when it is unsplit. And I is the number of records in each chain. So far we have assumed a binary split. When you assume a binary split, there are only two classes. Only two divisions, two nodes. For each division, one node, there are two nodes. But whereas if you split this here into k partitions, you will have k child nodes for the parent. So parent consists of n records and children consists of different records. So Ni is the number of records. Ni consists of number of records at each node, at node I. Now let's see how this goes. See, split into two partitions. Effective of weighted partitions will get larger and pure partitions are sought for. See, N1 and N2, there are two nodes here split. So for this, N1 has got 5 records of C1 and 2 records of C2. N2 has got 1 record of N1 and 4 records of N2. So this split has given a Gini index of 0.333. Before split, the parent has got 6 plus 6, 12 records. So this is the most impure aspect. Now with a kind of split, you have got Gini index of N1 as 0.194, that is 5 by 6 minus 2 by 6 whole square, 1 minus of that. And for the second split, it is 1 by 6 minus 4 by 6 whole square, 1 over. Are you clear with the Gini index calculation? Now the Gini of childs will be in their weighted average proportion. Because the first Gini is 0.194. 0.194 for a weight of 7 elements it is. So it is 7 by 12 into that much for node 1. And it is 0.528 for the second node. So here it is 5 by 12 into 0.528. So this plus this is 0.333. This is the effective value of your Gini index after split. So you have to consider the weighted average here for calculating the Gini of total children. So the Gini is 0.333. So initial Gini is 0.5. So 0.5 minus 0.333 will be the gain. So if the gain is more, the split is better. That means the sum of child Gini index of some of the child nodes should be as small as possible to have a better gain. That is one thing you have to understand. Now if you consider for each distinct value, you gather the counts of each class in the data set for categorical. Use the count matrix to make decisions. So you have a multi-way split here: family, sports and luxury car. See, previously with one example, we thought how we will be going ahead with different cars. You have C1 is 1, C2 is 4. Sports C1 is 2, C2 is 1.
Luxury
cars 1 and 1 for the multi-way split.
Again
For this multi-way split, you will
find out the
Gini index
like
1 minus 1 by 1 square minus 1 by 4 square, that aspect you will compute. And similarly these things. And the weighted average you will find out for the total things as shown in previous figure. So there the Gini is 0.393 if you have a multi-way split. Similarly, if you want to have binary splits, you have two options. One is sports and luxury cars, and another is family cars. That is one split. Another split is sports cars on one side, family and luxury cars on other side. So among these splits, you can look at the multi-way split has shown 0.393. And sports and luxury and family are shown 0.4, and carpet, sports, family and luxury on other side has shown 0.41. So the Gini is minimum for multi-way split. That means the gain is maximum for the multi-way split. So what you will do is you will consider all possible kinds of splits and calculate the Gini index. Or entropy, whatever it is. And using that, you will use the decide the one which gives you the maximum gain. Is it clear to you? Clear to you so far? If you have any questions, you ask me. Please don't hesitate. You type in. I will tell you. Hello. Please respond. Is it okay for you? So far? Hello. Please respond, my dear friends. Sports, family, and the luxury. One split you wanted to have. Okay, 1 second. Let me cross-check what are the things. Sports, luxury. And family is 1. Right. Another is sports is 1, family and luxury. You mean to say sports and family you consider as a luxury as one thing. Yes, it is a good question. But in this example, he has not considered. Right, I perfectly agree with you. It's a good point you raised. But you have to calculate the Gini index for that also. And whichever is minimum, you have to consider that part. I appreciate that. Real good question. Real good point raised by you. But in this example, he has not considered. Maybe you would have calculated it might be coming more, and she would not have quoted here from. But in really, if you are working with this, you are supposed to consider that part also. Okay? Good. That's a good question. Anything else?
concept.
Please
Please listen to this. This is
one more
important concept. You have to remember well.
Okay.
Okay.
We
We
use
use binary decision based on values, right? Now,
how do you split the continuous
attribute?
because it's a big challenge,
right?
So for
This, if you use a brute force method,
how do you
how do you go about it?
That means
You have to split on a continuous variable.
So you have,
If you look at, see the table that is shown here.
You have
You have 125K, 100K, 70K, 120K, 95K, 60K, 220K, 85K, 75K, 90K, like this.
Okay.
Okay.
Now in such case,
what is that you see? Previously, what is that you did for best split?
when you have
Three teams, you have considered multi-way split,
and
and there are three possible combinations. Of course, one possible combination is not shown there,
But you
but
have
to have three possible combinations,
And for
every possible combination you have to calculate the gain, right?
But here, in this case,
what you are supposed to do is brute force method means
you have to
make
for every
setup
you have to
split
is the
income
greater than
135 or less than or equal to 125.
You have to
consider
split the
record sometime. Compute the Gini index and gain.
Keep it
at place.
Then for
100 you compute the Gini index. That is taxable income greater than or equal to 100. For that you consider the splits and calculate Gini.
For 70,
for 120, for 90, for 60.
That means
for every record that is existing in the table, you have to check for a split and go ahead with. Right?
Do you agree?
If I do not decide any method, is it the way? Do you agree? Hello.
The brute force method needs to check every
value comparison. Do you agree with me in this?
Please respond.
Do you agree? Okay.
This is
where you have to do it. Now, what happens? Every time for every record to check the split, you have to scan the database. Do you agree? That means I want to find out how many records are greater than 95, how many are less than or equal to 95. I have to check means for that value I have to scan the entire database. Do you agree? So you need an operations for each computation value.
Is it
okay for you?
So for finding
out all possible splits and their Gini,
you have to
make n square operations. That is, for 125 full database scan, for 100 full database scan, for 70 full database scan, for 120 full database scan. Like this, for every record you have to make full database scan. So n into n is n square order. Do you agree with me? Now, if you have 10 records, that is fine.
But if you have a very big database table of a million records, it's pretty expensive n square order
and pretty inefficient also.
So they
worked out
one efficient
way
of representation.
This goes with
n log n complexity
only.
Because if you use quicksort and all, with n log n complexity, you can sort the entire table. Now, this is called the computation matrix. In this matrix, what you will have is the sorted values on the attribute which you have, the table that is sorted as per these values. Now if it is sorted, it is 60, 70, 75, 85, 90, 95, 100, 120, 125 and 220. These are the possible sorted values. For each sorted value, you have the class label. That is G, no, yes, no. Okay. That is for every value, you have this numerical value. Voice is not audible. Now, how is it? Is it audible now? Hello, my dear friends, please clarify, is it audible now? Is it clear and audible now? Okay, Chakravarti, you certified that voice is clear. Thank you then. Okay, fine. Now, please remember once you sort this, the sorted values of income are 60, 70, etc. and their corresponding, whether their cheats or no cheats is mentioned there. Now once for sorting, you need n log n complexity time. That is fine. Once this is sorted and kept like this, you will perform the process in this way. After that, you require only one scan to find out these things. How do you go about it? Please listen to this carefully. Sort the attributes and values. Linearly scan these values, each time updating the count matrix, and you compute the Gini index. Choose the split point that has least Gini index is the concept anyhow. Now how do you, sorting is done. Now how do you find out these things? Now the values are minimum is 60 and the other value is 70. So what you will do is, you find out the average of 60 and 70. That is 65. Okay. Then here the least value is 60. But what you will do is, you will consider the difference between 60 and 65 is 5. So you push it to the other side. 55 you consider, your 55 is not there. So you make the condition 55 you put less than or equal to 55 and greater than 55. Then less than 55 you don't have any elements at all. So it is 0, 0. At the end point also you have 220. What he has done is he has considered some 230, some other value. Actually you can say greater than 220 itself also there. That also doesn't make any difference. You can put less than 60. 60 also and ask for less than 60, not equal to 60. There you can ask for greater than. If you put less than and greater than on either side, that also will do. Not actually take 55 also. But somehow we followed that notation. I don't question that because it doesn't give any erroneous result. Okay. So it will be 0, 0. Now when the value is greater than 55 and less than or equal to 65, how the values are split. See, now what you are supposed to do is, you are supposed to take the average values of two consecutive numbers. So for 60 and 70, the average is 75. For 70 and 75, the average is 72.5, but it is considered as 72. And for 75 and 85, the average is 80. 80 is taken. For 85 and 90, it will be 87.5, but 87 is taken. That is the floor is taken. Okay. And 90 and 95, 92 is taken. 95 and 100, 97 is taken. For 100 and 120, it is 110. That is well taken. Similarly, 120 and 125, 122 is taken. The other value is 125 and 220, 172 is taken because 50, that is 7.5 will be plus 1.25 it should be. But it has added 7 only. As I said, 0.5 discarded. That means whatever is after decimal is discarded. So 172 is considered. The other one is considered as 330. But as long as you consider this with a greater than symbol, even if it is 220, that is fine, I think. And for 60 you can say less than, because if you put less than or equal to 60, the 60 value will come this way. So less than or equal to 55 as he considered, he has put less than or equal to. But if you consider 60 there, you can put simply less than. There is also another convention we follow. It doesn't really matter on either side. Now these average values are considered. Using this now, the split for 55, how did you split the values less than or equal to 55 and greater than 55? Now what happens? You will have less than or equal to 55, all 0 values only. Greater than 55, all the 10 values are there. Now among all the 10 values, if you consider you have 3 yes and 7 no. So now for the split, the Gini index is calculated. That is one. Second thing is 65 is considered. Because I can increase the volume here. See now, second split is greater than or less than or equal to 65 and greater than 65. For this now, you know pretty well, before that there is only one record, right? It is 0, One record only has passed when you are scanning. So you will have the count there. So it is 0 and 1. Because one record has passed. The total records will be 1. Among them, yes is 0 and 1. So now you can know that one record is on less than or equal to say, and on 60 greater than 65, remaining 9 records are there. So you have a kind of point kind of thing there. So from that you can comfortably find out, okay. So that means see, please remember here, when a single scan only you are doing this, each time you are not scanning. Now consider the other value 72. Now also what happened? Only 2 records have passed by. So less than or equal to you have 2 records greater than 8 records. Similarly, less than or equal to 80 and greater than. Again you passed 1 record. So each time what is happening? One record is being added. And you know pretty well for all the existing records how the split is on yes side and no side. So you can read that record and to which class it belongs to, you can add the count there. And the counts will be adjusted. Are you following me? Shall I explain you once more? Please respond. Is it okay? you say
you say you have understood, I will go ahead.
Okay, fine.
Okay, fine.
So here, one section. Okay,
fine. Vijayanagaram, you just wanted one more time to explain. Fine. See, initially, less than 55 when I am considering, you have no records. So, this split will be less than or equal to 55, no records, and all the 10 records on the other side. Agree?
So you have among the 10, yes are 3 and no are 7. That also have agreed, right? Now what happens? If you come to the second record, you know pretty well already one record has passed. Right? So now how can you say that next point is 65? So in the less than or equal to side, as one record has passed, only one record will be there on yes or no side. 9 records will be there on other side. Okay. So in that one record that belongs to no, you know pretty well. So it is 1 and 0. So remaining will be 3 and 6. Because in the nose 1 has come to the other side less than or equal to side. So 1 and 6, 0 and 3. Now you pass by. Then if you go to the next records and in 72, the value 71 has passed. So that means on the less than or equal to side, you have 2 records now. And greater than side, you have 8 records. If you push even that will come to the next thing. 3 records have passed. So 0, 3 and 3, 4 there. That means each time you know these some values. Yes, how many are there? No, how many are there? Once you come to the second thing, what you have said, one record has passed already, you decided. As you decided one record has passed, so from less than or equal to side, you have to make 1. On greater than side, you have to make 9. It is 1 plus 9. That is clear. Already you have got 3 and 7 as the values for S and no on the greater than side. Now what happens? Always from greater than side, one record will be pushed to the less than or equal to side. So for that single record which that has been pushed, you know pretty well that is no. So that means that one record, no side you have put 1. Yes side it is 0. And yes side 3 no change because the record has moved from no side. So that will be 6. Now if you push one record, how the totals will be adjusted is, on the less than or equal to side it will be 2, other side it is 8. Now if you see that for the sheet it is no only, the second record one. So that means from no side one more record has moved. So 5, 2, instead of 6, 1 it is 5, 2, 0, 3 remain the same. Next you are pushing one more record. These also on no side. So yes side it is 0, 3 maintained. 2, 5 has become 3, 4. Then if you consider this the other record is an S side. Now 3, 4 the bottom one will not change. It is 2, 1. Right? So that means each time only one record will be pushed in this split. So in the only one scan, you can fill up all these values, and as soon as you find out these values, find out the Gini index. And from the Gini index, you can just each time you can read which is the minimum Gini index value. Because picking up the minimum value also can be run, the program also can run in single go.
So
in one scan, you will get
both
Gene index
calculated.
You will calculate
all the records how they are being pushed. See, when it comes to the last, on the less than or equal to side you have all 10 records, on greater than side you have 0.
And
obviously you will be computing the Gini, and you are computing whether it is minimum or not each time, because the current minimum you can maintain every time, because in the first round you will think that 0.42 is minimum. Next when you have made the split, you will calculate Gini also, it is 0.4, so the minimum then is 0.4, so 0.42 will vanish. Then the minimum is 0.37 at that stage. Then 0.342. This is minimum. That will be the minimum. Again 0.417. Again 343 will be the minimum. Again 0.4343 will be the minimum. Then it is 0.3. Then this will be the minimum. So finally it will compute everything and compare with the current minimum. So by the end of the scan, whatever is the minimum value that remains in memory. So that current minimum 0.3 will be considered as the minimum Gini index thing. So for 0.3 the value there corresponding is 97. So the best split is that for you. Is it clear to you, my dear friends? So that is how you will find out the best split for a continuous attribute. Now the next slide is an alternative splitting criteria based on information. This is entropy. Is the information. Thing required. Because we have seen entropy means disorder. The measure here is minus J by T log Pj by T. What is this Pj by T? This is the relative frequency of a class J at node T. Or for your convenience it is considered as sigma I running from 1 to k, that means you have k classes. Sigma I1 to k, pi log pi to the base 2. So this is also a measure of homogeneity at a node. Okay? Its behavior is similar to that of Gini index only. Here also, if you have equal distribution file like the impurity is the maximum, and if you have all homogeneous things, the thing here is 0. So the entropy-based computations are similar to Gini-based computations only. There is no difference. Only thing is the values differ, but the graph will be one and the same for this. That means for the sinusoidal kind of curve, the amplitude changes, but the shape of the curve is similar. So I am again showing you the entropy calculations. Now you may have a doubt. Basically, I want to show you a kind of derivation. How you consider this kind of entropy as minus P log P. How come this is come into picture? It will be a quite interesting thing. Though it is not there in syllabus, but if you understand this, why only have considered Gini index and all these things we have taken? See, I'll come to the derivation. It's a small derivation for a short period, not take much time. See, if you consider again classes, there are total 6 elements, C1 and C2, 0 and 6. Your probability of C1 is 0 by 6, probability of C2 is 1. Entropy is minus of 0 log 0, minus 1 log 1. This is minus 0 is 0.
and
1 and 5
is
is the distribution.
Probability of
C1
C1
is 1 by 6,
C2 is
C2 is 5 by 6.
So your
entropy is minus 1 by 6 into log 1 by 6 to the base 2 minus 5 by 6 into log 1 by 6 to the base 2. That is 0.65. See, when you have 1 and 5, one small impurity is there. Entropy is 0.65.
So this
has increased the entropy by almost 35%. Previously it is 1. It is the entropy is decreased, I'm sorry, not increased, to 65%. Suppose if you have 2 and 4, the entropy is 2 by 6, 4 by 6 are the probabilities, 2 by 6 log 2 by 6 to the base 2, 4 by 6 log 4 by 6 to the base 2. The entropy is 0.92 with this. Now, how do you calculate the term gain? Previously, entropy of unsplit one, that is entropy P, the beginning, you have P nodes, and minus your sigma I is equal to 1 to k Ni by N into entropy of I. So that means, like your index calculation, you will compute entropy in each and every node, you will consider the weighted average, and you will sum up all the weighted averages of those entropies, and you will find out the sum of the values. That means what does it imply? After splitting, the total entropy is equal to entropy weighted average sum of all splits. That is the entropy after division. And before division it is the value at unsplit node, and the difference is gain. So more the difference, better the split is. Okay. So parent node is P has split into k partitions, and Ni is the number of records in each party. Ni is the number of records in a partition I. So measures reduction in entropy achieved because of the split. Now you will again find out the best split. Okay. Choose the split that achieves most reduction. So maximize the gain. ID3 and CART 4.5 algorithms use this entropy measure. The disadvantage is tends to prefer splits that result in large number of partitions, each being small but few. This is an interesting point to discuss. What he says is, if you have more number of splits, then it will become purer and purer, but you get an error. Yesterday I told you, right? If you have the classes like I'll show you the previous slide there. On student ID, when you have split, you have got the best performance, right? And I'm showing you that. Yes. This slide. See here. When I have split on a student ID, you have more number of splits. 1 0 1 0 1 0 0 1 0 1 1 0 like each is very few, and the sum is 0. But do you prefer the split? You don't prefer the split, right? Do you prefer the split? Do you prefer the split even if it is minimum? My dear friends, do you prefer the split if it is minimum? Please answer me.
have more number of splits, it will be purer and gain will be more. But do you prefer that kind of split? Please answer me. JNTUK Vijayanagaram. Do you prefer it or don't prefer it? More number of splits. I told you yesterday on roll number if you split it, in a class you will have 50 splits. Each is a pure thing. Do you prefer that split? Do you prefer that split? Please answer. JNTUK Kakinada, JNTUK Vijayanagaram, or any other college, Aditya, Pragati. Okay, good. They are saying no. Why? Shall I unmute you otherwise? Will you speak? You are seeing it produces more number of branches. Then what is the loss if you have more number of branches? I said it is a good split. What is the difficulty or disadvantage you have with that? See, I explained you. The difficulty here is you wanted to give some kind of classification. You said no. For what? No means no problem or it's not an issue. Though on student, if you get 50 splits and each class is pure and split is good, but does it carry any implication or any meaning for you? Right? Then from the decision tree, can you classify? Your decision tree is the root node. What is the student ID? On student ID, you made 50 classes there. So if another new student comes, what you will have? Yes, another ID or 0 or 1 it will be there. So that is not at all used for any decision making. Okay. Because your number of children are less means you are effectively grouping the things for some kind of information. Because in your decision tree, you have a smaller tree with larger group names. Whatever conclusion you are giving has got some basis for it. It has got some confidence. That is, suppose you have 100 records. You made it into 3 branches, almost having 30, 35 on different branches. Then whatever solution you give has got support of around 30 records for you to deal with. Whereas if you have one record, the decision, you cannot generalize a group decision there. So it should have sufficient confidence also. That doesn't mean you should have only binary split. You can have multi-line split also in certain cases, but you should limit to it. That is the reason why certain decision tree algorithms will exclusively confine to binary split only. Okay. So that's the reason why what they have put is Just if the gain is maximum is not alone sufficient. You use another measure called gain ratio. That is the gain you have considered. Gain is calculated as usual, but it is divided by the split information. What is the split information? Split information is your minus 1 to k ni by n into log n by n. So n by n is probability of it and log n by n. That is called split info. So your parent node is split into k partitions. Ni is the number of records in partition I. So adjust the information gained by the entropy of the partitioning, split info. Higher entropy partitioning is penalized. That means though your gain is more, if it is divided with split info, you are getting per partition what is the gain like. Are you getting this? So your per partition gain should be much higher. So that means this gain is divided among the partitions with a weighted average. So that's why you made it split info. And your count 4.5 algorithm uses this gain ratio instead of your simple gain. So it is designed to overcome the disadvantage you get out of information gain. Because the information gain, if you consider only information gain, okay, if the more number of partitions you simply divide into, you get a very good information gain, but it is of no use. So the number of partitions also should be limited. So in order to achieve that, the split info parameter is divide the gain, that is gain ratio. This disadvantage is overcome with this. Is it clear to you? Now how do you consider the classification error? Classification error is used as 1 minus maximum of pi by t. Measures misclassification error made by a node. 1 minus 1 by n by c, where records are equally distributed among all classes, implying least interesting information. So there is one more measure called error rate t. That is 1 minus max of p I by t. So this is about the information gain rate. And examples for computing error. Error is 1 minus max of p I by t, we consider, right? 0 by 6, 0, 6. You consider 6 by 6. So your error is 1 minus max of 0, 1. So 1 minus 1, error is 0. So here 1 by 6, 5 by 6, error, max of 1 by 6, 5 by 6, so 1 minus 5 by 6, 1 by 6. Error is 1 by 6 here. 2, 4, the error is 1 by 3. So the error is considered as 1 minus max of the probabilities of each partition. That is also another measure you consider in computing system. If you now consider the graphs of the thing. See the entropy part. The probability is consider the bottom 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9 and 1. These are the probabilities. The probability of any event will be there between 0 and 1, you know pretty well. Now the entropy or JNTUK or this classification error are being plotted. So for what ratio of probability, what is the JNTUK part or all these things. So I told you the shape is one and the same. For a probability of 0.5, the entropy or JNTUK or misclassification error are the maximum. for the probability of one means probability of one specific class is one implies any other class elements doesn't exist there. Because probability of this class is 0 means some other class is 1. Similarly, probability of this class is 1 means another class is 0. So this class is totally disappearing means it is the best thing. So the entropy there is 0. Again for class 1 also it is 0. Okay. So the entropy is plotted when you have a kind of curve like this where it probability is 0.5 means you have equal proportion with the other classes. So it is maximum. But here you look at the amplitude of entropy maximum is 1. Amplitude of GD is something like 0.5. And this classification error is also the same. Is it clear to you? Any queries? Any questions, please? Any questions, please? Now, in our methodology, we have seen how the gain or the parameter is calculated. Any questions? Say just yes or no. You respond. That is better. If you keep quiet, you don't understand whether you have understood or not. When to stop this? Is the next criteria. When to stop the splitting is the next criteria. Please respond JNTUK Vijayanagaram or JNTUK or Pragati. Have you understood? Now, the criteria is when to stop the splitting part. Stop expanding a node when all the records belong to the same class. That is one criteria. Or stop expanding the node when all the records have the similar attribute value. And sometimes you will have early termination. That will be discussed later. Why you will have a later. But these are the two conditions wherein you can stop. It is quite obvious. Okay. Now, what are the advantages of your decision tree? Inexpensive to construct this is one thing. Extremely fast at classifying knowledge records. Easy to interpret for small size trees. Interpretation is very easy. Accuracy is comparable to other classification techniques for many simple data sets. As far as this works out well for low dimensionality decision tree. And the accuracy is really comparable. But in practice, than decision tree, the Bayesian classifier is considered to be a better classifier in many applications. Example for a C.4 point. Simple depth construction is made. Use the information made. Sort continuous attributes at each node. Needs entire data to fit in memory. Unsortable for large data sets. It needs out of course sort. Okay. That is CORP 4.5. And practical issues of classification is underfitting and overfitting, missing values, and how do you classify the cost of classification. But as far as our syllabus is concerned, we have underfitting and overfitting issues and some missing value issues. But in this, I have to load because something that is prescribed in your curriculum is missing in this PPT. So I'll be just loading those few pages which you have missed for further classification, for further study and discussion. This is your actual textbook. Now you have the decision tree algorithm shown here. Your algorithm is included in the syllabus, whereas it's not shown in your slides. So I'm just showing this part. Are you able to see this algorithm? This is a recursively done algorithm for you. So I'll explain you this algorithm at this stage. Then I'll just afterwards if time permits, I will talk to you about the derivation of entropy. Why it is minus p. It's another interesting topic to really learn. Okay. So. Okay, you want zooming? 1 second. 1 second. I'll add. Point for a while. Mr. 1 second. 1 second, please hold on. Right, is it okay? Is it visible? Is it visible? Is it okay or you need little more zoom? I'll just focus. Exactly. Now, he is discussing about the tree growth algorithm. He said tree growth E, F. If stopping condition is of E, F is true, then
leaf is equal to create the node. Leaf dot label is equal to classify E and return the leaf node. Okay. Else the root is create node. Root dot test condition is find the best split of E, F and let V is equal to V such that possible outcomes of root dot test condition. I'll explain the steps. Don't worry about it. I'll explain your steps. Just go through the algorithm once. And chain is equal to again regrowth EV, comma, F. And you add the chain as descendant of root label as V and fur. This is the algorithm is given. Function. Okay, I is talking about functions. I'll talk from the beginning. Steps. Your skeleton regression algorithm called that regrowth is shown here. The input to this algorithm consists of training records. Because what is the input for your algorithm? You have to give a set of training records. That is the set of training records is E. And you have to give a set of attributes. Right? Do you agree with me? The input will be. What is the input? You are giving the set of training records and the set of attributes. So the algorithm works recursively by selecting the best attribute to split that is mentioned in 7. So what is that we did? Because why I am telling you the algorithm straight away is we have used before we have just studied how to have the best split and all, right? So here we have the regrowth condition E, F. So now two conditions arise when you have this algorithm. You have to check each time stopping condition is true or not. That means what is the initial input for you? Initial input is the number of records given to you. That's set total. Suppose I ask you to classify 100 records. So that 100 records set is readily available to you, given to you. Okay. Now what is the condition here? If the stopping condition is met, that means when 100 records are given to you, what do you think? Because I told you in my previous calls also, as and when all the 100 records are given, you will straight away check whether all the 100 records belong to the same class or not. Or you will check first of all this set is empty or not. Because I will give a null set for you to classify also. It is possible. So is it a null set? You have to check. Otherwise, is it a set with all records having the same class label? You will check. Then the stopping condition is met with. Or else another condition you have stipulated yesterday we discussed that the number of elements should not be less than the threshold value. If the number of elements is less than the threshold value, what you will decide that the maximum
number of elements belong to which class you will check, and you will say that their records belong to that class, and as the records belong to that class, you clarify that node belongs to that class.
Make it a leaf.
So these are the three conditions for the stopping criteria. So if the stopping criteria is true, that means you have to do this testing, because this weak algorithm only you will have major steps shown. Then if the stopping criteria is met with, what is that you have to do? You have to create a leaf is equal to create node. What is meant by leaf is equal to create node? The create node function will be executed. What kind of node it will be created? It will be the leaf node. Okay. So you create the node, you will label it as leaf. And leaf dot label. And what should be the label for that leaf? It should be classify E. What does this classify do? It will find out the class value of all the elements of E or the majority elements of E. That's what he has mentioned here in the next step. Classify. What does this do? The classify function. He is explaining here. The function determines the classify function. Classify function determines the class label to be assigned to a leaf node. That's the job of classify function. That means for each leaf node D, the probability IT means the probability of D, probability of the class that belongs to. Okay, there is a fraction of records from class I associated with node D. Then it is maximum of I by D, I running from 1 to K. In most cases, leaf node is assigned to the class that has majority number of training records. Okay. So the classify procedure will do that and classify the label there. And return the leaf. LLG. And you return the leaf. The root is equal to else what is to be done. Suppose the stopping criteria is not met. That means you are given 100 records. You know that all of them doesn't belong to class, or it is not empty node, and even the threshold value is more than the threshold value to split and off. So stopping criteria is not met with. Then the else part will come into picture. What is that you will do in this else part? You will create a root node. Root is your create node. And the root dot test condition is to find out the best split E comma F. So you have to find out the best split for the test condition. So root is create node. What does it do? It creates a node for you. You call this as root. Then root dot test condition is find the best split. So find the best split means what happens? You remember the logic what you have done for best split. You have considered all attributes, the attribute set is there. Now on each attribute you will find out the splitting criteria. If it is an attribute with binary values, you will have two splits to consider. If it is not a binary value, you check for multi-way split, or you make combinations of two-way splits and consider which split is good Otherwise, if it is a continuous variable, you will sort it and check as per the procedure we have given. So like that you will explore all the attributes. You will calculate for everything, either G index or the entropy, and you will decide which one to use there. So you will use the all possible outcomes. See here. What are all the possible outcomes of your root dot test dot node for the best split? So that means you have all these options. For all these options, you can find out a split which has got the best gain ratio. Because you are using gain ratio, not simply the gain before as we discussed. So you will find out with the best gain ratio, and that best gain ratio split you will consider. So in that you might be having some K partitions, right? So your V is a set such that you have small v is possible outcome of root dot test dot count. So what is the possible outcome of your root dot test dot condition? The K splits. So K split sets you will have. Now what is that you have to do? You have to create a node for each and every subset to grow the tree. Do you agree with me? So that is done here. For each V belongs to V, EV is equal to E such that root dot test condition is equal to V and E belongs to E. That means you will say, because what is that we said? What will be the content of any node? The test condition will be the content of any node, right? So EV is done. And you will make it as one change to the parent, that is your root is the parent there. So you will have change is equal to regrowth of EV comma F. Okay. So you will use this training data set for this thing as a change for the previous row. So add change as descendant of root and label the edge. Root gives change as V. Because what is that condition? Because for your decision tree, your branch is the outcome. Right? Your label is the condition. So the child will be labeled with root determines change, and it is end. Then return the root. So this is a recursive growth of your decision tree, and this is done like this. This is how the algorithm runs. Okay. Do you have any questions on this? Please tell me, do you have any questions on this? Do you have any questions on this? So if you do not have any questions here, what I can do is, I can stop here, and in our next class, we are going to discuss the overfitting problem and underfitting problem, how the decision tree training data set behaves, how the testing data sets behave, what are the kind of problems you face with overfitting and underfitting, and then how do you assess your classifiers. These things we will learn, and we will see the derivation for your entropy also in our next class. Probably I will try to finish this unit by the next class, that is the next Wednesday. Okay? So, see you then. We will meet on next Wednesday. Bye. If you have any question, don't hesitate to